Okay, Algebra 1 students, we are going to be making a recording here for the notes for solving one-step equations or Unit 2.5. First thing we're going to do is start with a couple of sample equations and use the method of plugging in a possible solution for x and seeing what happens. So in the first one, we're going to plug in 1 for the x and see what we get. So if we write that out, that becomes I'll write in black here, and it'll show the part that we plugged in pink. So I'm going to write 2. I'm going to leave space to plug in for the x plus 3 equal 5. Now I'm going to plug in that 1. And then we're just going to clean that up and do the math. So when we solve this equation where we plugged in 1, now we have 2 times 1 is 2 plus 3 is equal to 5, or 5 is equal to 5. And I would say, hey, it's true. All right, now let's try that on the next problem. Next time we're going to plug in a 0 for the x. I'm going to do the same thing again. Write this out and say 2 parentheses plus 3 equal 5. And this time, instead of plugging in 1 for x, I'll plug in 0. And then when we do that math, we get 2 times 0 is 0 plus 3 is equal to 5, or 3 is equal to 5. And hopefully you're thinking what I'm thinking. No, false. All right. So that means that the 1 was a solution, the 0 was not. So let's think about a definition that goes with that. So I think what we could say is that solving an equation is finding a value or values. Sometimes there'll be more than one, that we can plug in, put in place of a variable in an equation that makes the equation true. So what we're going to see is, unlike what we did at the beginning, was where we picked a couple and tossed them in, we'll be able to just solve for that true value. Let's do that on number 1. So number 1 says d minus 8 equal 17. Well, what I'm thinking about is I want to solve, find out what d would be to make this true. And that means I need to get d by itself. So the question I'm going to ask myself is, what's keeping the d from being alone? And I would say that it's this -8. It's in the way. So what's the 8 doing to the d? It's being subtracted. So I'm going to do the opposite. I'm going to add. So now we're going to add 8. Ooh, did not mean to do that. Oh dear. All right, so I'm going to say plus 8 on both sides. When I say both sides, I mean both sides of that equal sign. All right, so I'm going to add 8 to both sides. Now, when I do that, these two cancel out, and I just have d left on the left side equals 17 plus 8 is 25. So d equal 25. Solved. All right, so on number 2, negative 16 equals m plus 71. So we got to get rid of that 71. It's being added, so I'm going to subtract 71 from both sides. So now I have negative 86 equals m, because the 71 and negative 71 cancel each other out. We can flip that around and call it, we can just say m equals negative 86. Either one is okay. This way is more standard. Last problem of these first three is a weird one because it says 8 minus negative n equal 8. Well, regardless, we still have this 8. That's the problem. We got to deal with that. So that's being, believe it or not, even though there's a minus after it, the 8's really positive. It's being added to all this. So we're going to subtract 8 from both sides. Now we're left with negative n equal negative 7. Well, now that's negative, it's hidden in there. It's really negative 1 times negative n. Fastest way to do this is just say that negative times negative is positive, and that makes it n equal negative 7. And we'd be done. Or you could go the long way and divide both sides by negative 1, and then divide by negative 1 again. So we're going to leave it like that. Let's move on to number 4. All right, this time, w minus 7 equal 9. Think to yourself, what's keeping w from being alone? What's it doing to w, and how do I undo it? The thing that's keeping w from being alone is the negative 7. It's being subtracted, so I'm going to add 7 to both sides. Very simply, w equals 9 plus 7, which is 16. J plus 5 is negative 10. Subtract 5 from both sides. So now J equal negative 15. That's kind of an ugly J. All right, number 6. Negative 13z equal negative 13 equal negative 39. This one's a little bit different because, I guess we'll stay black. The negative 13, even though there's a minus sign in front of it, what's it actually doing to that z? It's multiplying. So in order to undo this, we have to divide both sides by negative 13. So now we have, and that's because negative 13 divided by negative 13 just becomes 1, positive 1. So we're left with z on the left is equal to, when we do the math, a negative divided by negative is positive. 39 divided by 13 is just 3. Rolling on. Negative 180 equal 15m. All right, what's keeping the m from being alone? 15. What's it doing to the m? It's multiplying. That's 15 times m. So how do we undo that? We divide both sides by 15. So now we have, those will cancel out. We have just left with m on that side. Negative 180 divided by 15. If you toss that in your calculator, it's just going to give you negative 12. So m equals negative 12. Number 8, a divided by 4 equal negative 3, or a over 4 equal negative 3. Well, the way we undo, well, right now what's happening to the a is being divided by 4. How do we undo that division? We multiply by 4. And so those, that 4 and 4 cancel out over there, and we're just left with a equals negative 12. So number 9 is 1/5 of p equal 8. Remember, of is times, so that's really 1/5 times p equal 8. How do we undo multiplication? We divide. Now we can divide by 1/5, or you may remember that we can multiply by the reciprocal. So we could multiply this by 5 over 1. Because 5 over 1 times 1 over 5, let's do that real quick. 5 over 1 times 1 over 5. We multiply straight across, that's 5 over 5, which is just 1, which is what we need it to be. We want it to be 1p. Now let me get that out of there. Easier said than done. So we know that we can divide both sides or multiply both sides by 5 over 1 or just 5. So I'm going to multiply right side by 5. And now we're left with just p equals 8 times 5, which is 40. Okay, last three. All these involve fractions. J plus 2/3 equal 5 over 9. Well, right now, what's the 2/3 doing to the j? It's adding, so we're going to subtract. So I'm going to write this out again. J plus 2 over 3 equals 5 over 9. Needed a little more room. Well, we know we want to subtract 2/3 from both sides. So now the one on the left, that's not times, that's minus, is just j equals 5 over 9 minus 2 over 3. You may remember that with fractions, you can't add or subtract them unless they have the same denominator or the same number on the bottom. Well, in this case, the numbers on the bottom don't match. We can actually easily make the 2/3 match the 5 over 9 by simply multiplying it by 3 over 3. So if you're multiplying by 3 over 3, you're really multiplying by 1. So let's do that. Let's take that. I'll go up above here and write negative 2 over 3 times 3 over 3. So that now we can multiply straight across, which is negative 6 over 9. So negative 2 over 3 is the same as 6 over 9. So we write this again as 5 over 9 minus 6 over 9. That I can do because they have the same denominator. That's just going to give me negative 1/9 because 5 minus 6 is negative 1. So j equal negative, I should have done a different color. J equal negative 1 over 9. All right, 11. K minus 1/7 equal 2/3. What's keeping the k from being alone? The negative 1/7. What's it doing to the k? It's being subtracted. So we have to do the opposite, which is to add, or the reciprocal action. Opposite, sorry. This time, I'm going to pick the color, black. I'm going to add 1/7 to both sides. So on the left side, negative 1/7 plus 1/7, that just leaves k over there, is equal to 2/3 plus 1 over 7. Now this is a tricky situation where there's nothing I can do to either one of those fractions to have it be the same denominator as the other. So what we're going to do is multiply each of them by the other one's denominator. So let me show you what I mean. I got 2 over 3, and because the other denominator is 7, I'm going to multiply by 7 over 7 times 7 over 7, which makes that 14 over 21. Now the 1/7, I'm going to multiply by the other denominator, which is 3. So that's going to be 1 over, oops, That's going to be 1 over 7 times 3 over 3, because that's the other denominator. And that's going to give me 3 over 21. Notice now, let's see, I can use yellow. Oops, mark it up. They both have the same denominator. So I changed 2 over 3 to 14 over 7. I changed 1 over 7 to 3 over 21. They're still the same number. They're just have they've grown on top and on bottom, but they're still the same ratio. So now I have, if I rewrite this, k, oh, gotta stop doing that. K equals 14 over 21 plus 3 over 21. They have the same denominator, so I can add them together. That's k equals 14 plus 3, which is 17 over 21. And there's nothing I can do to simplify that. That's as far as we can go. All right, we got one to go. Negative 3/8 of h equal 4/5. Well, this time you may recognize this negative 3/8 is times the h. We could divide by negative 3/8. That's fairly complicated. Another rule is that if we want to get rid of a fraction that's multiplying something, we multiply by its reciprocal, or we flip it. So that's going to be times negative 8 over 3. And if we do it to the left side, we better do it to the right. And you will see that the reason for that is negative 8 over 3 times negative 3 over 8 is equal to 24 over 24, which is just 1. So now the left side becomes 1 times h, or just h. Now the right side, though, we have that fraction to multiply. So let's pick a different color here. We can go back to black. We have 4 over 5 times negative 8 over 3. Well, that's on top is going to be negative 32, and on bottom is 15. And unfortunately, there's nothing I can do to simplify that. So our final answer here is going to be h equals negative 32 over 15. I suppose if you wanted to, you could find that to be a mixed number fraction, which is going to be h equals 2, or negative 2 and 2/15. But for what we're doing, leave it like this. That's it for today. You should recap by saying in your own words what is a solution to an equation. Remember, if you need to, you can go back and look at my definition earlier. Thanks for watching. Hope this was helpful. Bye now.